Hey everybody. I was just getting this video together here so we can take a look at energy levels and electrons and everything about ions, since I wasn't not here last Thursday and you guys had a whole bunch of subs, and the subs they probably don't have a good idea on how to teach energy levels and ions, which is kind of tough. So anyways, let's go ahead and take a look at this. So today in class, and this is what I was wanting to do, but like I said, I was gone. Let me fix the zoom on here. Oh, a little too small. Anyways, we had some pennies, and the pennies were acting like the electrons, okay? And so if you guys go to your table, I gave you guys a table online that looked a lot like this, except you already had a couple ions on here. So like if I put Li plus, right, that's lithium plus, that's an ion. So an ion, the only thing an ion is a charged particle, where an atom is a neutrally charged particle, right? So if I had a lithium atom, let's go ahead and do lithium here real fast, right? So you're going to fill out these tables, and you guys may have already done this. At the end of this video, if you guys want to redo this assignment and email it to me, or if you haven't turned it in yet, that's totally fine. I would suggest you guys probably want to redo this, okay? But anyways, if you haven't turned it in yet, just go ahead and turn it on Teams with it, after watching this video, or you can email me another copy and just say, hey, I would rather you grade this copy than the one that I turned it on Teams, and I totally understand that. Anyways, so let's go back to our diagram here. So we're doing lithium. Oh my goodness, this is going to be tough, guys. Li plus. All right. So we know lithium. If we go to our periodic table, you guys have a periodic table. You guys should be looking at a periodic table at all times. We have lithium right here. All right, so we know lithium's atomic number is 3. So how many electrons would a normal lithium ion have? A normal lithium ion would have 3 electrons. So 1, 2, right? 2 electrons fit in the first energy level, and then we go to the next energy level. So we have our 3. However, we don't have an atom here, right? We have an ion. This is charged. Lithium's charged. And so what the electrons are, these guys are all negatively charged, right? And so what's going on here is we have 3 positives, right, in a normal atom, in a normal lithium atom. And then we also have 3 negatives, right? And you guys know if we do some simple math, that gives us 0, which means that's a neutral charge, okay? But we don't want that. We want a positive charge. So how do we get a positive charge? Well, we need less negatives. So we need less electrons. So let's get rid of that electron out here. So instead of having 3 electrons or 3 negatively charged little subatomic particles, we only have 2. So if we put positive 3 charge to our negative 2 charge, that gives us a 1, right? 1 positive. So that's, if I just have one positive sign, that means 1. If there's 2 negative, that means there's 2 negatively charged, and 3, and so on and so forth. But anyways, that's how we get lithium plus. So we still have our 3 protons here in the middle, our 3 positive charges, right? Because remember, if we change the number of protons, then we will change the element overall. But here we are plain and simple just changing the charge of the ion, right? So there's lithium. That's how you want to do lithium. And so if we went over here to our table, number of protons always has 3. That will never change, right? Number of electrons, it's 2. So how many in level 1? 2. But then these other guys have 0, 0, 0. And that's because, so when we make ions are made because they want to act like a noble gas, right? If we look at our noble gases, if I can find I got a lot of tables pulled up, but here's my noble gases, helium. If we look at the electron configuration, helium has 1 energy level with 2 electrons, right? And that's full because the first energy level can only hold 2 electrons. If you come down here to neon will have 2 energy levels. That second energy level will have 8. It has a full valence shell, right? If we talked about it last class, valence means outer. So valence shell means the outer energy level. And that outer energy level, everybody wants to have that full, right? We talked about in class today how a valence shell wants to be like a hotel. It wants to be full. It doesn't want to have any empty rooms. So neon has a full valence shell. Argon has a full valence shell, right? Full valence shell. All these guys do. And so fluorine has 7 electrons in its valence shell. All of these guys in group, this is group 7. All of these guys have 7 electrons on their valence shell. So they need one more electron. They'll gain one more electron in order to have this electron configuration. So if they gain one more electron, that means these guys will become negatively charged ions. Okay, so if we come back over here to lithium and hydrogen and sodium and potassium and rubidium, these alkali metals here, these guys will actually lose an electron. So lithium lost an electron and then had the electron configuration of helium, but became a positively charged ion because he lost an electron. Where these guys over here will do the opposite. They'll gain an electron to become that. All right, let's try one more together. So let's try one of these negatively charged ones, right? So let's try chlorine, fluorine, bromine. It doesn't really matter. Let's try chlorine. Or let's try fluorine because I'm terrible at drawing. It takes a long time. Okay, so let's go edit. Clear the ink. All right, so we said fluorine. And our ion is going to be -1. So we'll just put a minus because that means -1. So fluorine, we know on the periodic table that this guy is -9, right? All right. Or sorry, he has 9 protons. So that must mean that normally if he was neutral, he would have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And so, like I said, if we come over here and we look, how do I get my color here? All right. So if we come over here, our valence shell is vacant. All right, here's our vacant room. We don't want to be vacant. We have room for 8 electrons and we only have 7. So fluorine, right, this ion, the reason why fluorine will become a negatively charged ion is because he wants to gain an electron from out in the space somewhere. So this electron will be accepted right here and give us fluorine, -1, right? So fluorine has 9 protons, right? 9 positive charges. And now, since we gained an electron from the environment because this valence shell wants to stay full, we have 10 negatives. That'll be negatively charged, right? So then that gives us a negatively charged particle. All right, one more, I promise. This is it. So let's do one that has a bigger charge. Let's go with oxygen. So oxygen. What's going to be our ionic charge? Or this is actually called the oxidation number that we put up here. Okay, so we know if we look at oxygen over here, oxygen's right here. He's 2 away from being a noble gas. So how many electrons may he gain or lose? Well, will he want to lose 1, 2, 3, 4, 5 electrons and become charge 5 plus? Or would oxygen rather gain 1, 2 electrons? So if you gain 2 electrons, those are 2 negatives, right? So then it'd be -2. The answer is oxygen would rather go this way. He'd rather gain 2 electrons to get to this noble gas configuration. It'd be easier to gain only 2 instead of losing 5. Okay, so we have our 1, 2, 3, 4, 5, 6, 7, 8. So let's remember oxygen has 8 protons, right? 8 positives. The atom does, right? Always 8 protons. But then we know that he also has 8 electrons, but we're going to make an ion here. Well, we have these 2 vacancies, right? This guy wants to be a hotel. He wants to fill up all of the rooms. So we still have room for 2 electrons. to make this guy that noble gas electron configuration. Let's fill up our valence shell. So these guys will be inserted here. There's 2 negatives, right? So instead of having 8 electrons, we will actually have 10 electrons. So if we have 10 electrons, we have 2 minus. Okay. So then that's how our oxidation number, right, would be -2. Okay. So the only other one that gets any bigger than oxygen is aluminum, which is +3. So he would lose 3 electrons. But anyways, go ahead and finish out the rest of this table. So I guess I can help you fill this out. If we have oxygen -2, oxygen -2, right? So that means he still has his 8 protons. He has to keep his number of protons the same or else he will change. He gained 2 electrons. So that's how we got the -2, right? Essentially, you will take this column and subtract it from this column. But we know that he had 2 in the first energy level. He had 8 in the second level because he wanted that full valence shell, and then these guys are empty. All right. So like I said, I know I gave you one that these ones are out of order for the table that you guys got. That's totally fine. Just kind of fill that in the correct way. But please email me. Let me know if you guys have any questions on this stuff. Bye.